Hello there. In this video we're going to talk about another property of discrete random variables, namely the variance and second moment of that random variable. In the last video we talked about the expected value or the mean of that random variable, and we're going to use that in a couple of these derivations. So firstly, let us define the variance of a discrete random variable. So the variance of a random variable. So variance of a discrete random variable. So we're going to define it in a very similar way as we did the expected value. So the variance for the random variable x, which sometimes you may see written as sigma x squared, is going to be defined to be equal to the sum of x minus mu x squared multiplied by the probability of x. So you're going to take all of the values, x, subtract the mean or expected value, square that difference and multiply by the corresponding probability of x, and you're going to do that for every single value of x. Now that may seem a little bit more tedious, so we're going to derive a more simpler property that may be more efficient to use. Alright, so let us take this expression here and let us expand it out. So that means that the variance for x is going to be equal to the summation of, so what do we get when we square that out? So that's going to be equal to x squared minus 2 mu x plus mu x, the quantity squared, multiplied by p of x. So then this is going to be equal to the summation. I'm going to distribute the probability in. So this is going to be equal to the sum of x squared times px. And then we have minus 2 mu x times px. And then we have plus mu x squared times px as our three terms. And now let us distribute the summation across addition. So this is going to be equal to the sum of x squared px. And then we'll notice that 2 is a constant and mu x is a constant, so we can sort of factor that out of the sum. So it's going to be equal to minus 2 mu x times the sum of x times px. And then again, this mu x squared is a constant as well. So we can factor that out of the sum, and we have mu x squared times the sum of px. So this expression gives us a little bit of things to look at. So first thing is, this is almost like the expected value of x, but instead of x here we have x squared. So this is what we call e of x squared, or the second moment of x. And we'll describe that later. So this is going to be equal to e of x squared. And then minus 2 mu x times, well, this is precisely the definition of the expected value of x, or mu x. So that's just mu x. And then plus mu x squared times, and since p is a probability mass function, the sum of the probabilities here is equal to 1. So therefore, sigma x squared is equal to the second moment of x minus, well, mu x times mu x is just mu x squared. And then we have plus mu x squared. And then these are common terms, so we can combine them. So then we have sigma x squared is equal to the second moment of x minus the mean of x squared. Now you may see this written in a couple different ways. So you may see it written as sigma x squared is equal to ex squared minus the expected value of x, the quantity squared. And of course this is the same thing as writing the variance of x. So this is one common notation. But if we look at this notation and add mu x squared to the other side, then we also get the identity that the second moment of x is just equal to mu x squared times sigma x squared. And this is another useful identity as well, if you know one, or you need to know one of these three components. So pretty much what do we have here? So if we have e of x, this is the same thing as mu x. This is calculated by taking the products of x and px, multiplying them together, and adding them up. Then the second moment of x, which we write as ex squared, is just equal to the sum of x squared times px. So you take all your values, square them, and then multiply by their probabilities. The variance of x, which sometimes we write as sigma x squared, is equal to the summation of x minus mu x squared times px. But we also know that this can be calculated by the second moment of x minus the mean of x squared. So these are two different but equivalent ways of calculating the variance. So we have one important relationship, another common but not so important, but the third is definitely important as well. So from the variance, you can also calculate or define the standard deviation of a discrete random variable. So STdev of x, or as some people may write as just sigma x, is just going to be equal to the square root of the variance of x traditionally. So that means sigma x is calculated to be equal to the square root of the second moment of x minus the expected value of x squared. And that gives us some identities. So let us just go through one basic example. So suppose we flip one coin. So one coin results in heads or tails. So that means what? So let x represent the number of heads that you can get. So what is all the possible ways or values that x can have? So you can either have 0 heads or 1 heads. So that means what? So what is the probability that you get 0 heads? Well, that's going to be the same as the probability of getting a tails. So that's going to be 1/2. And the probability of this one is going to be 1/2 as well. So if that is the case, that means what? So that means the expected value of x, which is the summation of x times px, is just going to be equal to 0 times 1/2 plus 1 times 1/2. So that's of course equal to 1/2. So if you flip it, one time, you're expecting that half of them are going to be heads, or whatever that means, right? And if I want to calculate the second moment of x, that's just going to be the sum of x squared times px, which is going to be 0 squared times 1/2 plus 1 squared times 1/2. Now, of course, that's equal to 1/2 as well, right? This example is not really that interesting, but it will give you some insight on how to calculate things for more complicated examples. So that means what? So that means the variance of x, which we already discussed to be the second moment of x minus the expected value of x squared. So the second moment of x is going to be equal to 1/2 minus the expected value of x is 1/2 squared. So it's going to be 1/2 minus 1/4, which is of course going to be equal to a quarter. So if that is the case, then that means the standard deviation, and of course people sometimes write that. So that means the standard deviation of the random variable x will be the square root of the variance 1/4, which is of course 1/2. And that's just a bit of theoretical discussion of the second moment, variance, and standard deviation of a discrete random variable. In the next video, we'll do a couple examples that are a little bit more in depth and not as trivial.